Hello everyone. Today we are going to discuss about the Capstone Project 9 about integrated retail analytics. And yeah, this is my project summary, which has three data sets, including 45 stores, 81 departments, and 143 weeks. That is from Feb 10, 2010 to October 2012 to show the economical indicators like CPI, unemployment, fuel price, temperature, and other markdowns as well, five markdowns. And first, I did data wrangling and I merged those three data sets into single master data set. And I've got around 420,000 rows, which is a very big data set, and performed uh, the 15 EDA charts along with pair plot and heat map as well. And yeah, for anomaly testing and machine learning algorithms, I used IQI testing and random forest and logistic regressions and XGBoost methods for three testings. And I used a basket of a priori to store weak data. And yeah, as I've told you, I've used linear regression, random forest, and gradient boost, XGB boosting for finding out how my data is. And finally, I translated the analytics into strategy, and I have marked down all those data and concluded that. So yeah, that is my GitHub problem. And I want in the problem statement. I wanted to conclude and find out the reasons of four major problems in the dataset and the issues. That is the demand that is volatile and which is seasonal, and promotional markdown data which is incomplete for five markdown fields, and external economic factors. That is the main important topic of this capstone project as well, and no customer level transaction data exists. That four problems will be seeing in this capstone project with ML algorithms as well. And yeah, coming to the libraries, I've imported all the basic libraries and visualization libraries like matplotlib and seaborn params. And for statistics, I've imported from SciPy and sklearn processing for training the data and finding out how the test data is working on the ML algorithms. And yeah, coming to that, the models are isolation forest, random forest, gradient boosting, and HGB as well. And for warnings, I didn't want to show all the warnings as well, because when I was importing and performing operations on uh, estimators on machine learning algorithms, I've been getting a lot of warnings in that. So I didn't want to show all the warning signs in the dataset to make it uglier. So I wanted to ignore the algo warnings as well. And yeah, I've loaded the three datasets: stores data, sales data, and features data. Coming to the parsing, I parsed it because the datetime format is in like a string format. So date format, I wanted it to be a string format for performing operations on that columns. So I parsed that data from datetime format, and the shape as well. Sales is having 420,000 rows. The first view of the dataset, as you can see, there are the first views. This is what we've been talking about in the problem statement as well, that we don't have markdown data for the first few months at least. Yeah, this is the row count of my dataset, and information about my dataset, what type of data type we are having in my datasets. Most of them are integer, object, Boolean data types, date time. This is what we converted from string type to date time data type, and float, integer, And the columns in features are of Boolean data type, date time, float, and integer. I wanted to check the duplicate values if there are any in the datasets, but we didn't find any, so we didn't get any datasets. And null values also, we didn't find any null values in the stores dataset and sales dataset, as we found out that in the markdown values there are missing data. Uh, we can see that there are around 4,000 rows among all the data. How many rows do we have in this? We have around 8,000. So half of the data is around missing from the markdowns. And we have few missing data in CPA and unemployment as well, which is around 10%. So I wanted to visualize my data, which we have missing values. Most of the data is missing in markdowns only, and very few from CPI and unemployment. I wanted to show how much percent of data is been missing in the uh, columns. So as we can see, 65% is max missing data, and that too in only markdown columns only. Most of them are missing in markdown columns. So that is what I mentioned in my data set as well, that those three data sets and features, and how many columns, no duplicates, but the ranges of weekly salaries are negative to negative means we are getting returns in the salary, and up to the max sales is 6,960 693,000. So yeah, these are all my columns in my data set, which we have around 12 to 8, 15 columns in features data set. As you can see, I'm describing my data set more here, all the datas for all the columns and for all the three data types. These are the all the variables that are available in the three data sets, sorry. Checking any unique variables are there in each each one. As you can see, I have printed all the unique values for all the types. And yeah, this is the main segment of my data wrangling, with the whether how and what I did with the three data sets individually. I have merged stores dataset and with the sales attributes with left join, so that all the data would be coming from the sales data set, the 420 columns, 420,000 rows, and I merged it again with features data set. And c- coming that, as you can see, I merged that with free features data set here, and I have created new columns for the data set, which is for the date type uh, individually, so that I can perform more EDA analysis on the data types with the given data, which is so vast. And I wanted to see what is the spend down on the markdown table, so I've modified that, and I've put NANs in my dataset, which is having no value in the markdown column. So I've printed the master data type, master data shape. As we can see, we have 420,000 and 22 columns. After creating new columns and merging with each three data types, three data sets, this is what I've been performing, and this is the insights that we found, the manipulations that I've told you earlier. And coming to the visualizations, there are 15 visualizations that I wanted to perform around univariate, multivariate, and bivariate analysis. So the first one is total week sales across all the stores over time. As you can see, in from the data is ranging from 2010 January to 2012 September. So as we can see in thousands, and this is to the power of 7. So 4 million and 5 million, 6 million total value is in salaries. So as you can see, we have a highest peaks around 2011, uh, 2011 January and 2012 January. So January is around the peak time where people and analytics is high in the weekly sales. That is what I've been given here in the analysis and insights as well. That in November, as you can see here, from November it starts, like in Thanksgiving and in December for Christmas, we'll be getting more sales. And coming to the chart two, that is average weekly sales by store type, we can see that store A is producing more average for weekly sales. After that B and after that C. But there is a significant difference in A to B and B to C as well. As you can see, that is what I mentioned here. Weekly average is differing, roughly double with compared to type C and type A. And the chart 3 as well. Chart 3 is the total sales in millions, and for the department type, I've segregated with each department. As you can see that department number 92 is producing the highest total sales in millions. As you can see, the top five are 92, 95, 38, 72, and 90. We are producing proportional of higher sales is what I can tell you in the terms of revenue. And yeah, coming to the chart 4, chart 4 is weekly sales for holiday sales and non-holiday sales. They are almost the same. As you can see, I have also wanted to show the range as well in the median and mean. As you can see, if there is a holiday and the mean is 15,000, and if there is holiday, there is not a holiday, the median is 7,500. And if there is a holiday, the mean is 17,000 and the median is 7,900. The variation is very, very little compared to holiday and non-holiday, because now holiday values are only between Thanksgiving and Christmas. So that would be ranging in October to January for the other 2 years as well. That would be arranging themselves to give us high means and high medians values. That is what I mentioned here as well. And coming to the chart 5 shows store size versus average weekly sales. As you can see, red is type A, blue is type C, type B, and green is type C. As we seen earlier, that type A shops are producing highest sales in the average weekly sales. So we can see that shop A is store A is towards to the right, followed by type B, and followed by type C. Whereas we can see that type B is scattered for medium and also less sales. Chart 6 is about weekly sales by month. As we know that in the previous chart we saw there are highest sales for Thanksgiving and mm, Christmas. So we can say that the sales will be highest in October to December. After that, we would be having from February and March as well, which are the early months. So people will be celebrating, and uh, we will be in the mood to have to buy. So yeah, that's why we have February and March as well for and later comes June as well. June is the summer season, so people will be having holidays in June as well. And next comes the distribution of weekly sales for the count. As you can see, there the highest is lying between 1200 to 1500 is what I can tell you, is what I assume. Yeah. So yeah, I wanted to show this through a histoplot. because we can see the KDA as well for that, and we can follow how the trend is and how the skewness is for the distribution. As we can see, that is this is a left skew. It's not around the median and mean as well. This is a negative area. So if we wanted to see if there are any negative values in the data set, that also I wanted to print. That is what I wanted to show, that there will be a skewness of motivation. Coming to chart 8, that is the markdown value availability that comes over time. As you can see, from 2010 January to 2011 October, we don't have significant changes. But after that, to that 2013 07 is September, we would be having a significant change in the markdown values from there, because all these values are nulls. So as we saw earlier, we imputed those values with NINs. So from 20 November 2011 is what I told you. From November 2011, we have all the data for the markdowns as well. As we can see, there are reporting infractions for all the markdown values, and there is only markdown 5 that is with a constant ratio. Next is the chart 9. The chart 9 is economic indicators over time, which shows the average CPI, average unemployment rate, and average fuel price that is affecting the sales from July 2011 to July 2013. As you can see, the average CPI is elevated from 168 to 178 over 1 year, over 2 years, and average unemployment rate is decreased from 8.5 to 7, because more people are being employed in the sectors. That is a very good thing to know, and which is a very positive insight for the uh, firm. And average fuel prices will be, as you can see, that there is a overall there is a increase, but there is a significant decline in the fuel as well. But overall, we have a increase in the data for average fuel price over 2011 and 2013 July. Coming to chart 10, that is temperature versus weekly sales bands. As you can see, we have I have segregated temperatures into bins of uh, 10 degrees each. So we can see how much sales is going on with respect to the temperature. As you know, Thanksgiving is like peak autumn and pre-winter region, and thanks Christmas comes in the winter season. So temperatures would be low, and around uh, these all temperatures are in foreign heat. So uh, uh, as you can see that 26 to 26 degrees is like normal uh, room temperature in India, but the in the data set, that is winter season. This is summer season here in 69 to 78. So yeah, as you can see, the sales are higher in June for the summer season, and in December as well for Thanksgiving and Christmas seasons. Coming to chart 11, that shows a pair pie chart for store type compositions, which gives us information about store count by type, and total sales share by type. In the first, as we can see that compared to A, B, C type, A has more store count in the data set. After that, B has 38%, coming to C with very less stores, around the 13%. And among the 49% of the A stores, which is producing around 64% of total sales for from all the revenue that is produced. And coming to the 38% of B stores are that is producing 30% of total sales of share. And as C is already less in comparison with the A and B types, but that is also being able to produce 6% of the total share by the type. And yeah, coming to next chart, that is which shows the total sales by year, which is in billions. Uh, as you can see that IE9 is in billions. So as you can see, the chart range is for 2010 to 2012, and which is around 2.25 billion to 2.5 billion. There is a significant rise in around 25 to 50 million in from 2010 to 2011. And there is a fall in sales by the year for the years 2011 and 2012, which is the same around the increase for 2010 to 2011. As you can see, I have mentioned here as well, it is around 2.28, 2.24, and 2 billion in the range. And coming to chart 13, that is a spiked chart for weekly sales for in holidays and weeks that are highlighted. As you can see, we have weekly totals and their red dashed highlights as well. This is around Thanksgiving and uh, Christmas sales. And here also in Thanksgiving and Christmas sales, we can see that there are total weekly sales that is highest. And coming to the correlation heat map, which is with respect to all the columns that is available in the integer data types. Here in the numerical columns, I've told you in the integer data types, I've taken only the numerical columns to make the chart look good. And as you can see that store size shows strong positive correlation with weekly sales, and markdown columns are also mutually correlated to each other with CPI, unemployment, and fuel price. CPI, fuel price, and unemployment. And coming to the pair plot, I wanted to show with respect to weekly sales, average sales, and size, CPI, and unemployment. As you can see the charts, which is scatter plots and also area graphs for the data types and for the columns. And yeah, coming to the hypothetical testing for three hypothetical testings, I wanted to show the hypothetical testings for whether holiday effect is there in the average weekly sales, and whether store type is affecting the average weekly sales, and whether store size is in relationship with the average weekly sales. Coming to the hypothetical statement one, the first one is the mean weekly sales is equal on holiday and non-holiday weeks. As we saw earlier, that there are with respect to holiday and non-holiday, during holiday seasons we have total sales as highest. Now we have using an algorithm we are going to prove that that is true, and the hypothesis, alternate hypothesis is that they differ according to the data set. We need to get that the um, null hypothesis must be rejected. Let us see whether after performing hypothesis in p-test and t-test statistic results, that after using Welch's two sample test, we found that the reject has been confirmed, that sales differ on holidays and non-holidays with p-value is 0.00. I wanted to perform with the 0.05 alpha value. So yeah, the first hypothesis is failed. And coming to the second hypothetical statement, that is mean weekly sales must be equal around among the data stores A, B, and C. But that is according to the data set that is wrong as well, because A produced higher total weekly sales and C produced around 6% data sales that we saw in the EDA charts. That must be proved with the hypothesis as well, as if we are correct and the algorithm is true, we must reject the hypothesis performing that. So for the second one, I've used a one-way ANOVA test to perform and to check whether we are failing the hypothetical statement or not. And as you can see that the total mean type is exactly different for all the three data types, three stores, 20,000, 12,000, and 9,000. As you can see that if statistical is differing and p-value is also less than our expected value. So we'll be rejecting the hypothesis as well, which is being proved. And coming to the next one, as I've told you, I've performed one-way ANOVA test. And third hypothetical statement is to prove whether average weekly sales is being in relationship with the in relationship or not. Uh, as you can see, there is no relationship because there are different number of stores and different amount of total weekly sales that is performed. And as you can see that in the EDA charts of fair pie plots, we proved that different amount of stores produces around 60%, 30%, and 6% of data total weekly sales for three data types, the stores. So according to the data set, we must reject and let's see whether we got that in the same data set hypothesis in the that we are going to reject or not using Pearson correlation test. I've I've got Pearson value as 0.8 and so according to the p-value, if it is if it is less than 0.05, we are going to fail. Or otherwise, we are going to reject sales correlationship. So there is the relationship that size and sales are correlated to each other. Coming to the missing values, as you can see, there are missing values only in markdown values and very few for CPI unemployment that is being filled with NAS and using lambda functions. I imputed that with lambda functions, and after that, we treated that and printed that there is no missing data values here. That is what I've printed here. And coming to the outliers, if there are any outliers I wanted to show using altering floor negatives and log 1p values. So I wanted to show whether there are values with respect to IQR ranges and print them. Uh, yeah, as you can see, I have printed that values and negative correlation values are also there around 1285 rows, which are retained as real holiday demand. That is what I've mentioned in the insights as well, that we have negative sales and there are high outliers among the values which are very differing from our IQR range, Q3 minus Q1. And I've also wanted to categorical encode for the store type, which is A, B, and C. And I've got that type A has holiday values, which is encoded for one hot version for linear models. That is what I've mentioned here as well. So as you can see, textual pre-processing is only for NLP or sentimental analysis or text data clustering. We don't have any analysis and performing on uh, this numerical columns. So I'm going to skip this section. That is what I mentioned here, that there is numerical data, so we need not perform any of this. Uh, for the feature manipulation, I have taken store department and date, and I found out how are they related to each other for with each other. That is what I found out after creating new columns. Uh, after grouping them with each other and finding out how are they related to each other, whether we are getting values on those data types or not. As you can see, we got the data as well in the tabular format. And in the second feature selection, I've selected all the feature columns that we performed analysis, EDA analysis on, and wanted to show how are they related to each other using SK metrics using random forest for 20 estimators. It took a lot of time to give me the output, but finally it gave me an output for all the data types I wanted to show visually as well. How much the is the importance of a feature with respect to a random forest analysis. That is around, if we are taking from range for 0 to 1, lag 1 is related to about 0.8 range, which is highly related to features so the if this column is removed, so the data will be definitely affected for other feature analysis as well. Later, data transformation also for the data type that we saw for the superset for weekly sales. This is left skew for original one, and after performing analysis, we got that is a log one is right skew. So that's why we have skew as negative value. And data scaling, we can scale our data for how much ever we want, but I wanted to show for minimal data. So I used standard scalar format. As you can, that's what I told you. So we used a standard scalar format. That means we would be having zero mean and one unit variance format. So for all the features that we wanted to show, this is the main thing that we wanted to see, the tree based models. How are they affecting the features for the size, the temperature, fuel price, CPI, unemployment, and total markdown. As you can see that the mean and standard deviations are almost zeros and ones. And coming to the dimensionality reduction, I've used principal component analysis for that. And I've experienced the variance ratio and cumulative value as well for all the important factors that are affecting the data set. And coming to the data splitting, I've performed 80-20 data splitting only for the normal splitting procedure. So because there are around 420,000 rows, so if there is around 20%, we would be getting around 80,000 rows. So that is what it is here for testing. So yeah, if there is around 80,000 data set, that is a very much data set for testing our model algorithms for the other 80%, which is 338,000 rows. So we would be getting for around 2012 April to less than that, we would be getting those rows for training data, and the other dates for 2012 December and 2013 January and all those will be coming under testing data. So we can see how our data is performing. As you can see in the isolation forest anomalies in the weekly sales after performing IQR analysis, and we can see that we have the IQR anomalies around 8.43% and isolation anomalies at 2%. That means the contamination is 0.02 after smart sampling. And coming to unsupervised analysis, the segmentation, and this is for market strategy. So as you can see, I have used the elbow method and Silhouette score to check how our k-means is performing in our data set. I wanted to perform that n clusters, six clusters for ranging like 2 to 8. So it would be iterating our data sets for 7 times. And random state is 42, which is a common data set with a 3 cluster data set, which is to interpolation for interpretation of high volume or medium volume or lower volume data set. So we found out that as we decrease the k value, the inertia is reduced on Nilbo method, and for which is almost similar to Silhouette score as well, which is the lower logarithm graph for the two types. This is also shown in two principal components for store segments, segment 0, 1, and 2 in different data types in which is performing in PCA space. And coming to the next is segmentation quality analysis. As you can see that uh, we are having silhouette score has more, and Davis Bulletin index is high, which is not a correct value, and Kalinske-Hallberg index is higher, which is a good ratio. As you can see that higher average sales and low sizes as well for the data. And for the market basket analysis, as you can see, I have performed using ML extend using a priori is what I've told you earlier as well for the association rules. And this is what I've got for which departments are performing, and according to what, how many association rules, and how much is the confidence of the dataset. If it is more than 80% only, we would be considering for our analysis and taken into the result output. So I these are the top 10 values. The As we have 248, the I wanted to print out a few outputs, a few output, and this is the same visualization for the same for the above chart. This is a simple how this strategy is involved and how the data is produced in the real world data set is what I wanted to show an example. And coming to the ML models, the first one is linear regression model, and the second model is this is the chart for all the data set that we wanted to predict, and that is predicted data. As you can see that lies in the same range as well. And coming to the second data set, I've used grid search data, grid search CV to perform whether the data is performing and giving the result as an accurate or not. And the second one is the random forest regressor. As you can see that the actual value and predicted value also lie in the same zone, but this comes with the interpolation of the zero axis as well. But we have an intercept here for random forest. And next comes with histogram based gradient boosting, XGB GBR boosting, which gives the results. And I wanted to show all these three to side by side to see whether which one is performing and which one is giving highest accurate model. As you can see, the R2 value, R square values are root mean square errors and mean absolute errors and whole mean absolute errors are almost in the same range. But coming to the choosing the best model for the among these three, I got historical gradient boosting values are more compared to the uh, other two, which is very small change. So compared to those three is what I've been choosing historical gradient boosting values. And this is a small feature work whether my data is performing correctly or not according to the historical gradient boosting, and with iterations and all. I wanted to save that file as a .pkl file so that we can use it in my future analysis. So I've loaded that data and performed whether the range is the similar or not, and wanted to perform whether my training data and testing data is in the same range or not. I have almost performed like at the actual and prediction range. The 16,000, 29,000, 16,000, 17,000 is almost similar. 17,100, 17,900 is almost similar. 18,100 and 18,100 is similar here. 18,500, 18,300. So this is what my predicted data is, and that is what I wanted to say in my conclusion as well, that historical gradient boosting is performing more accurately among the data for the given three data sets. That is for the integrated retail analytics for the three data types, three data sets. Thank you.